Hey everybody, today we're going to talk about inequalities and the sides of triangles. We're going to be on page 25 in your packet. All right, so this is the first thing that you need to remember. The sum of the smaller two sides of a triangle is always greater than the third. All right, so if you take the two shortest sides and add them together, it has to be larger than the third side. Otherwise, it can't make up a triangle. So if we look, 3 and 4 are two smallest sides. 3 plus 4 is 7. Is 7 greater than the longest side? No. So it's not a triangle. All right, the two shortest sides here are 2 and 2. Together, those add up to 4. Is 4 greater than 3? Yes. So they could be the sides of a triangle. All right, on this one, 4 and 6 are our shortest sides, which adds up to 10. 10 is greater than 9. So yes, those could be the sides of a triangle. So your first theorem today, the two shorter sides have to add up to be longer than the third. All right, another way that they could ask you this, it says if two sides of a triangle are 6 and 15, what are all possible third sides? Find the range of all possible values. So that means there's going to be more than one. All right, now if 6 and 15 are the shortest two sides, when you add them up, you get 21. So the third side could pretty much be anything less than 21, but bigger than 15. All right. But then you got to look, well, what if 15 was the largest side? Then you got to try and figure out all those values. A very quick way to do it is add them and subtract them, and then pick all numbers in between. So if I add, let's do 15 minus 6 to start. If we do 15 minus 6, we get 9. If we do 15 plus 6, we get 21. So your x values can be any, make that a little bit better. Your x values can be anything between those. All right, for example, let's say it can't be 9 because 9 and 6 would be 15, and those don't add up to be greater than 15. So it's not equal to, it's just greater than. So it could be 10, 11, 12, all the way up to 20. But it cannot equal it. And we're writing it like this as a range because you can't forget all the decimals in between either. All right, so again, add them, subtract them, and then just pick all the numbers in between. I mean, you could play around with values too, but. All right, a few more little tidbits about triangles. If two sides are not congruent, the larger angle of a triangle is across from the longer side. So the larger angle is always across from the larger side, which makes sense because the more open an angle is, the further apart the endpoints are going to be. And the converse is true. The longer side is across from the larger angle. Now, just like anything else, if you can draw a picture, do it. It makes more sense. So it says in triangle ABC, measure of angle A is 60, the measure of angle B is 40. Name the longest side of the triangle. Well, let's draw a triangle. A, B, C. Measure of angle A is 60, 40. Okay, well, we have to figure out what C is. Well, 40 and 60 add up to 100. So if we do 180 minus 100, C is 80. So what's our longest side? It's going to be across from the longest or the biggest angle, just like the hypotenuse is across from the right angle. So side AB is the longest because, again, it's across from the biggest angle. So 3 important things there. The two smaller sides have to add up to be larger than the third. If you want to find the range of all possible values and they give you 2, subtract them, add them, and pick everything in between. And then the longest side is across from the biggest angle, and the shortest side is across from the smallest angle. All right, so we're going to write the angles in order from smallest to largest. You might say, well, we don't know any angle sizes. Well, look at your sides. The smallest is going to be across from the smallest angle, or the smallest angle is going to be across from the shortest side. So find the shortest side, 17. Which angle is across from that? F. All right. And when you're listing angles, don't forget your angle symbol. Some of you are forgetting that. All right, the next biggest side would be 19.6, so next would be angle H. And finally, angle G is across from our longest side, so it's our biggest angle. All right, write the sides in order from shortest to longest. Again, look at your angle measures. We have 60 and 72. Let's add them together. And we'll do 180 minus 132 to figure out what angle R is. It's asking us for the sides in order from shortest to longest. Be careful, they'll, sometimes do it the other way. So our smallest angle is 48. So PQ is our shortest side. Next we have 60 would be next, so QR. Or RQ, it doesn't matter. And then 72 is our biggest angle, so side PR is going to be our longest side. Okay, shortest side across from the smallest angle. And just a little Pythagorean theorem review. I know we've done a lot with this the past few days, but just let's make sure we have it written down somewhere. A squared plus B squared equals C squared, where this is always your hypotenuse. And your hypotenuse is always across from the right angle, no matter how your triangle is drawn. All right, and A and B are your legs. Some common Pythagorean triples, remember that work every time. We've talked about those before. Basically, if you plug these in, 3 squared plus 4 squared equals 5 squared. Your longest side's always your hypotenuse. This will work out perfectly. So this gives you 25, and so does that. All right, just a little tidbit. You don't have to memorize those. Okay, so let's take a look at 1A. Our C, our hypotenuse, would be x. So it's 4 squared plus 8 squared equals x squared. All right, we can put that right into the calculator, or you can do it out. 16 plus 64 equals x squared. So 80 equals x squared. Round to the nearest tenth, so I'll take the square root of both sides. And what happens there is it gets rid of the squared. So then when we do the square root of 80 in your calculator, 8.9. It was 8.94, but 8.9 is where we're at. Okay, we're actually going to wait on this one. All right, we'll be coming back to it, so don't cross it out. All right, and then the last question that we have to look at today, tell whether a triangle can have sides with the given lengths when n equals 4. So instead of them giving you the 3 sides, you just have to substitute n in. So this side would be 4 plus 6, which is 10. This side would be 4 squared minus 1, so 16 minus 1 is 15. And this side would be 3 times 4, which is 12. So it wants to know if these 3 sides could be the sides of a triangle. Remember, the two smallest, 10 and 12, have to add up to be larger than the third. 10 plus 12 gives us 22. That is greater than 15. So yes, those could be the sides of a triangle. And when it says explain, this is what you did right here. You're explaining using math. All right, so we're going to be working on similar questions in class tomorrow. Give these a try so you can get a head start. The only one, let's see. No, I think you're good. The only one you don't have to do right now. Oh, actually, no, it does give you the perimeter. I didn't want to give you any with factoring. So remember, for perimeter, you add up all the sides, set it equal to 34. So we'll be working through those, and that's pretty much it for the chapter. If you have any questions, let me know. But you should have copied this down in your packet. Again, pages 25 through 27. Just some stuff with triangles to finish up the chapter. Have a great day.